Okay, let's proceed with the exploded view. So kind of thinking everything should come out the front. So if our auto space components is on, I will take those three first, and we'll go that way. And then I can kind of treat those as a group. Make them a little bit closer. That looks like a pretty good spacing, and then we'll go done. And then the shaft and the keyway. And let's see if we can add the bearing in there. That would probably get us a little bit more. Okay, so on the assembly side, what ends up happening is we would press the bearing in and the shaft and the keyway. So I might want to look at changing the order. And the keyway looks like it's staying engaged there. So that wouldn't be too bad if I go back and we look at chain 1 and maybe bump that up to 7 inches. Now we can do the up arrows, give it a little bit more, and that would kind of be the order of the assembly. And done. And let's see if we go back to the spacing. I probably just messed that up, but keyway jumped back into there, but that's not really the direction that I want it to run in. So chain. Well, if I've got to select those, I really want the keyway to be first and the bearing next. Nope, it's going to jump that out there. So would be nice to change the order. See what we have here. Roll back, reuse. Let's go ahead and hit done. The other thing would be if I really wanted that chain to be in a certain, we would just clear those selections, turn off the auto space, and we would bring the keyway out first. And realistically, the keyway is going to be on the opposite side. Oh, and I kicked myself out, so we'll go back to the configurations. And notice the chain is the group where the explode step is the one item. All right, but we can still see the chain there. And so since I had 6 inches, maybe we'll go back to 5 inches. Okay, and done. So I have that habit of hitting the check mark. You'll probably do that once or twice. And then this can come out to there. And wanting to hit the check mark again before I hit done. And then the last one would be to pull that out. It would be kind of nice to be able to see the shaft, so maybe a little bit more just to kind of illustrate how that's going to go together. All right, so that's good enough. Again, I can always try again if I don't decide I don't like it. Let's see my save warning. Let's go ahead with a file, make drawing from assembly. We'll pick our ANSI landscape. I want to bring in the isometric, and I did not grab the isometric explode, so usually I will pop that guy in over there. We can go back, and there is the isometric. So this is the advantage of the the view palette, and we get our bill of materials in. All right, so tables, bill of materials. I usually right-click first, but since it's popping up off of my capture screen, we will go ahead and put in the bill of materials. And that one has a little bit more since we use the McMaster, but I'm still not interested in the descriptions so much, and that will give us a little bit more. So the alignment that we ended up with, I'm just going to break that alignment and bring this one up a little ways. We'll scroll down in the feature and the custom scale. We can go to maybe half scale. I might be able to sneak that in there. Probably not. All right, so if I go from 1 to 5 is the sheet scale. Let's see, custom scale, where is the user defined? So use model text scale. And if I go to its properties, nope. Try to make sure that I'm getting hide components. Nope. User defined. Well, let's go to like 1/3. All right, so that one got a little bit bigger. We need to send this one back to sheet scale, and actually 1/3 isn't too terrible. So if we give it a little position there, then we can go to the auto balloon. I want to line them all up at the bottom, and that looks pretty good. So the only thing I would do is go grab some of these arrows and point them to where it looks a little bit better. Not sure how it picks, but and I don't really want those to cross over. And then if I grab the magnet line and move it a little bit, we can position those to where it looks halfway decent. All right, my graphics card is leaving the shadow lines there, so let's go ahead and we will go back to, let's go with the model view first, and then we'll make sure that you know how to do it from the view palette. So the support, let's see, are we going to need a side view? If I create multiple views and go that way, I probably don't need a side view, but the size, we're going to be back at 1/5, and apparently it left the sheet scale. So again, if I wanted to do user define that 1/3, 1/4, and we're not going to be scaling the drawing, so having somebody try to figure out 1/3 is not a concern. All right, so my first iteration or my first pass on the drawing is to go through and set up the views. Usually I will try to go in the order of the assembly. So we did the model view. We can also find the model view from the insert drawing view model. If we go to the view palette, then we're going to have to hit the ... and I made a note to remember what the name of those dots was, but yeah, I didn't. All right, so the right side view would be fine. It goes into projected, and then we'll go ahead and accept, and I'll go back into projected so we get that side, and that looks pretty good as far as an isometric view. We should be able to do 1-to-1 on these guys. Pretty close. Maybe the isometric view would go a little bit smaller. All right, and then the parent view will drag all of those. All right, so the isometric, we would shift over to a custom scale and send it to 1/2. All right, next would be the link. All right, and because the key and the bearing are purchase components, I'm not going to create models for those. We have the part number, or we have some information otherwise. If I needed the key, I might add that description column back in and put a description in. Um, there's a couple ways to approach that. So let's go through the view palette one more time. Browse, link, open, drag in the front view. And that one's going to be a little bit big. So we'll go ahead and accept those. Really only need the two views. And we're at 1:1, so let's go to 1/2. And that looks pretty good. What else do we have then? If I go this way, insert drawing view model, we're going to browse to the ball. And for it, let's see, probably create multiple, the front, the right, and the isometric, and we'll see what we get. All right, so for our components, if I go back to sheet 1, the bearing has a part number. The key we could define a little bit better, maybe the 0.19 by 0.25 or something into the naming, and give it a little more on the description. All right, so the second pass will be to add the dimensions, but this is where we're going to really want to start thinking about the tolerances. So our first pass, and I'm still in millimeters, grams, and seconds, so maybe we'll switch that out real quick. Let's go with a center line since that did not get put in. Select view. Didn't really like that one, so let's pick the outside two edges. That gives me a center line, and the center line will be to define these guys. And it picked a vertical, and we could go 3 inches either side, but we'd have to consider the tolerance zone of this can shift, and then this could also shift. So when we think about nope, did not want that. We'll try again, make sure I'm getting between the two center marks. And we're going to place those. Get that cleaned up. So pretty much we want 6 inches plus or minus, well, with the 2 decimal places, plus or minus 10 thousandths. And let's see, hole call out, I think we just made those, but it is finding 2 times the 0.052. And we need a vertical component there. All right, so let's see what happens with the hole call out. Oh, and that got pretty big all of a sudden. So if we do it that way, it's going to call it out as the counter bore, and we're going to have to go through and define that. But for expediency, let's stay with that, and it will also be a good example of finding the 0.162. So somewhere in there, the hole spot, modified diameter. And I just saw that. All right, let's grab that. Now that should allow me to change that that precision without changing all of those. So I'm not seeing my list there, but let's go ahead with the 3 decimal place. That shifts everything over. And going to delete that out real quick and double check it. No, it's not pulling those out separate. So not sure which one I was looking at. But I should be able to pull those on the individual items. Okay, so that's one of those. On the next pass, we would go try to figure out what I told it there. All right, so let's go with the 2 inches. Now I put a couple of model items on this. So if I do model items, import items into all views, into the destination, and we just want to bring in marked for drawing. Oh, didn't find any of those. So, oh, I did find those. So there is my inspection dimension. Now it doesn't really need to be an inspection dimension here. It was more so that we would verify it and be able to find. Now notice it is in the slightly darker color for the geometry. So we can either try to change that around with the format painter, or not, because it is an imported model. I can always just go back and reapply it. All right, so I know that that's another one of those. I know there's a way to do that. We'll just have to find it. All right, so from the base to the center line, and then if we're going to work off of center lines, we would go to the 4-inch. And if I want another center line here, then we're going to pick up those. And grabbing the handle, I can stretch it out a bit and get a little more length on that center line. It kind of represents the geometry. So we just have to think through the stack ups and find out where I can change the tolerance on that counter bore. So usually there is a list in addition to the dimension text and the diameter of the hole that allows each one of those to go individual. So I will have to define that because I don't really want to put 4 decimal places on everything here. I would just like to the one. So they called this out as a spline, and I'm going to do the same. So the 3/4 inch shaft will probably show up better there. Let's see, if I hold down the shift and go to the circle, that would be better on that one. And we would go to the 3 decimal places there. I would prefer that is, let's go to the select, would prefer that is a diameter. It sees it as an arc because there's a break in my selection. And then for the chamfer, let's go to more dimensions. Chamfer is all the way at the bottom, of course, so I'm just slightly off of my screen. And when we pick a chamfer, we want the chamfer edge and one of the, and the problem is here it's got that little bit of relief. All right, so 0.06, let's bring that up that way. And realistically, that is going to be the 2 times. So in this case, tolerance precision, second tolerance precision, that would be for the angle. This one would be for the tolerance. That's kind of what I was expecting on the hole. So 2 times, and kind of the difference here is the small x and the big X. The big X is a notation that I added it, where the small x and the space is a notation that it was generated by by SolidWorks. So the 2 times both ends, and then to put our node in there for the spline 4, let's see, it would be on one of those guys. And we could put the 4 spline by, what did I do, 1 inch. And I really didn't take care of the end geometry because depending on how we create the shape, it's either going to have the little swoop at the end, you know, whatever geometry builds it. All right, let's do a rebuild and see if I actually placed that or if it was, yeah, it was a carryover. Single source, the result. Nope, still in the notes. So I'm just trying to make those match a little bit better. So 4 spline by 1 inch, close enough. And we'll go to the link. And I would like to have some center marks on this since it didn't come in for holes. And create the view. Not seeing the preview. All right, so center mark for all holes. Not going to do that. It's not picking those up, so having some strange things going on here. Well, let's try the view. Center mark for all holes. Nope, not letting me have it. Well, the slots then have at least that much to go on, so that's a little strange. I'm not sure what's going on there, but radius of 0.75 between the two, 450. Hole call out. And if I do the hole call out here, has the radius of 0.38, but if we select, is that going to allow me to go over to diameter? I didn't see it in the context, but it will let me go that way. And the 0.75 here, under the value, we would want to go to the 0.13. And if I made this a bilateral dimension, I might want to just go up 1,000th and 750. So that's going to kind of denote it as a ream for the build. And then for the width of the keyway, and as a general rule, we're going to put both dimensions in there. And we have that geometry, and then we'll put in the shift select and go that route. So, well, at some point we're going to have to make the decision if we want these all to be 3 decimal places and go to 2 decimal places on some of them where we can, or we're just going to pick the 3 decimal places. So if I go 3 decimal places there and there, and then of course the width. All right, so one of the reasons that we have design review and drawing review is that I'm going through and I'm putting my best guesses at these into the mix. And when we go to review and actually start to do the tolerancing, then there'll be a little bit more involved. So the hole call out, 3816. And let's see if my center marks are going to work on this one. Okay, maybe I just wasn't getting it selected. So the issue on manufacturing this is not all CAM programs, lathe programs do a very good job of creating this spherical geometry. So it would be one of the considerations. Is this going to be a purchase part? Is this going to be an injection part? If we can find a knob with this geometry back on our master, then we would note this as a purchase or a manufacturer. But the issue is going to be that when we come over here, and we'll wrap up with this, is that everything is called out as steel. All right, so mild steel is going to be cheaper than stainless steel, but all of these really could be aluminum for the amount of torque that we're going to be able to generate with a 4.5-inch link and a spline shaft. This is so completely overkill that I'm not sure what the function is, but we've reproduced it, and then the next stage will be to design for manufacture.